previous classes we were discussing the questions where Kp, Kc or equilibrium constant. Constant that will does not change with change in temperature, pressure, volume. That will change with temperature. So that will not change with pressure, volume, concentrations, etc. But alpha will change with change in pressure, volume and concentration. So the example it is asked that at a fixed temperature, volume of the reactions container is halved. So volume is changing. So for this change, which of the following statements hold true regarding the equilibrium constant Kp and degree of dissociations? Neither Kp nor alpha changes. No, alpha will changes. So Kp changes, but no, alpha Kp does not change. Both Kp and alpha change. No, Kp does not change, but alpha will change. Yes. So option D is correct. So next topic, that is observed molar mass. So this is actually can represent by M. Suppose N2O4 gas and this is NO2 gas and T equal to 0. This is 1. Now product has formed and T equal to equilibrium. So 1, suppose alpha has consumed. So this is 1 moles. From 1 moles alpha has consumed. So for 2 moles 2 alpha will for so observed molar mass. Suppose if observed molar mass of N2O4 gas at equilibrium is 80 gram per mole. So it means that at equilibrium N2O4 gas, the observed molar mass is 80 gram per mole. So at T equal to equilibrium means this N2O4, the mass has consumed. Alpha has already consumed, so it is not a real mass. Because at T equal to 0, that is having real mass. But when T equal to equilibrium, so alpha from 1, alpha has already consumed. So we cannot get the real mass. This is the mixture of N2O4 and NO2 gas we will get. So this is the 80 gram. So 80 gram is not real gram. So if you calculate the real grams, so real molar mass of N2O4, we find that is 14 into 2 plus 16 into 4. That is 28 plus 64. That is 92 gram mole inverse. So this is the real gram. So this you will get when T equal to 0. Initially N2O4 has this amount of gram, and when T equal to equilibrium, 1 minus alpha has consumed from that N2O4, that real grams. From 92 grams alpha has already consumed. So that is 80 gram more, 80 gram per moles, and 2 alpha is 4. So this is the mixture of N2O4 and 2NO4. So that's it, at equilibrium 90 gram mole inverse observed molar mass is getting. So when T equal to 0 and NO2 has not poured, so at that time we are only getting the molar mass of N2O4 only, that is 92 gram. And when T equal to equilibrium, in our mixtures alpha has consumed from 1, that is real mass, and 2 alpha from NO2 is poured. So this 80 gram per mole inverse is from the mixture of N2O4 and 2NO2, because at the equilibrium we are having 1 minus alpha plus 2 alpha. So this amount of grams has been consumed from N2O4, and at the same time 2 alpha has formed from the NO2. So at equilibrium we are getting the 80 gram per moles. It means we are getting these grams is the mixtures of N2O4 and NO2, because from real mass of N2O4 alpha has already consumed, and from NO2, that is the new gas, 2 alpha is entered in the mixture. So this gram is the mixtures of N2O4 and NO2. So this is the molar mass of the mixtures of N2O4 and NO2. So they are asking so if I say the observed molar mass, so observed molar mass we depend as M, that is total molar mass of the mixture divided by total number of moles at in mixture at equilibrium. Okay, so if we say total mass of the mixture, we cannot write the NO2 molar mass. Why? Because NO2, from that only 2 alpha has formed. 2 alpha, we know alpha is very small. So 2 alpha, so very small amount of NO2 has formed. So very small amount of NO2 is formed, so we cannot take that, we cannot add the NO2 grams here. So a total molar mass of the mixtures means at T equal to 0, NO2 has not formed on that time. So on that time real mass is only the molar mass of N2O4. And when T equal to equilibrium, on that time some amount of NO2 has formed. So on that time we will add the molar mass of both N2O4 and NO2. So from N2O4 1 minus alpha has formed, and from NO2 2 alpha has formed. So total number of moles in a mixture at equilibrium, on the time we can add 1 minus alpha plus 2 alpha. So total molar mass of the mixture is only N2O4, because at T equal to 0, only this N2O4 molar mass is present. So M equal to, that is total molar mass of mixture divided by total number of moles in mixture at equilibrium. So we may confuse that total molar mass of the mixture means we have to add both the molar mass of this and molar mass of this. No, actually at T equal to 0, only N2O4 is present and 2NO2 that has not formed. And if you say at the equilibrium also, that from 1 alpha H consumed from N2O4, and alpha is very small amount. So 2NO2 also 2 alpha H formed. It means we are understanding alpha is very small. So whenever we are taking the total molar mass of the mixtures, we will take only the real mass of N2O4 only, not 2NO2. And total number of moles in a mixture at equilibrium, we can take on that time both this 1 minus alpha what is consumed and the 2 alpha. So M, that is real molar mass total number of moles mixture at equilibrium. So this m is observed molar mass, that we can represent as m, and this real mass is can represent as m. So real mass of N2O4 is 92. So you can write it 92. And total number of moles in a mixture, how much? Total number of moles in a mixture, that is 1 minus alpha plus 2 alpha. So this will be 1 plus alpha. So this will be 1 plus alpha, and this is m. Observed molar mass. So if you search, if asked that observed molar mass of any gas, that is equal to real suppose X gas, then the real molar mass of that X gas divided by total number of moles in the in a mixture at equilibrium. So this we can represent as m. So this we can represent as m. So let's say N2O4 gas, 2NO2 gas. So at T equal to 0, this is 1, and no product has formed, and T equal to equilibrium. So 1 minus alpha has consumed, so 2 alpha has formed because 2 NO2 is present. So here observed molar mass of N2O4 gas is equal to real molar mass of N2O4 divided by total number of moles. So total number of moles is how much? 1 minus alpha plus 2 alpha. So I am taking the observed molar mass as m. So and the real molar mass is m, and this is 1 minus alpha plus 2 alpha, total number of moles. So this we can write m 1 plus alpha n minus 1. So the n so this is 1 plus alpha. Let's say another example. Suppose A gas is going to give to C gas. For this case, if you search, suppose T equal to 0, this is 1, no product has formed, and T equal to equilibrium, 1 minus alpha has consumed, so 2 alpha has formed. So from 1 mole, suppose it is right 4 moles, then it will be 4 alpha, and if I write NC, then it will be N alpha. Similarly, if I write here Ma, then I will write M alpha. Okay, so for this case, observed molar mass M, that is equal to real molar mass. So real molar mass divided by total number of moles. So total number of moles is 1 minus m alpha plus n alpha. That is, I will take this is m and this is real molar mass, that I take m, then it will be it will calculate, let's say 1 minus alpha, otherwise calculations will become tricky. So let's say for understanding simple examples, so 1 minus alpha and n plus alpha n alpha. So for this case 1 plus alpha n minus 1. So here n is number of moles in product side. This is the observed molar mass. So suppose we have A gas is going to give 2B gas plus 3C gas plus 4D gas. So for this case M equal to real mass and this is T equal to 0, this is 1, this is 0, 0, 0, 0, and T equal to equilibrium. This is 1 minus alpha, this is 2 alpha, this is 3 alpha, this is 4 alpha. So M equal to, so M, that is observed molar mass, equal to real molar mass divided by 1 total number of moles, 1 plus alpha n minus 1. So n represent the number of moles in products. So 1 plus alpha, how many? 2, 3, 5, 4, 9. So 9 minus 1, that will be m 1 plus 8 alpha. So we can find this way. So let's solve one problems. Example, like N2O power gas, H2NO2 gas, if observed molar mass of N2O power gas at equilibrium is found to be 80 gram per mole, then ask calculate alpha. So for this, what you do, N2O power gas, that is equilibrium with 2NO2 gas, and when T equal to 0, this is 1, nothing has formed product, and T equal to equilibrium, so 1 minus alpha H formed, so 2 moles is there, so 2 alpha. So and you know the if you have to find the real molar mass of N2O power is how much? That is 14 into 2 plus 4 into 64, that is we get 92 gram per mole. So observed molar mass of N2O power, that is represented by small m, is equal to real molar mass of N2O power, that is represented by m, capital M, then total number of moles in the mixture at equilibrium. So observed molar mass, that is given 80. So 80, and real molar mass is 92, and total number of moles is 1 minus alpha plus 2 alpha, that is 92. That is 1 plus alpha, this is 80. So if you take it, then 80 plus 8 alpha equal to 92. So this will be 80 alpha equal to 12. Then alpha equal to 12 by 80. So 12 by 8, that is, we can do that, 12 that is equal to 1.5. So alpha is 1.5. So like this, like from here they will give the observed molar mass. They ask to calculate alpha, or they may ask to calculate the, like they will give another problems, like we can solve another, like they will give observed molar mass they will give, and alpha value they will give. So here they have given the observed molar mass, and they are asked to calculate the alpha. Okay, so next type problems, they will give alpha and ask to calculate observed molar mass. So we can easily calculate, because m equal to, capital M 1 plus alpha n minus 1, and they given the alpha, then we can put the alpha, and this n we can get from the equations. Suppose A gas plus B gas will be there, 3C gas plus 4D gas, then n is equal to number of moles in the product. So how many moles are there? 3, 4, 7. So we can put the value of 7, n equal to 7. Like so, n we will get from the equilibrium. So from equilibrium we will at equilibrium, what are the total number of moles in product side. So from there we can calculate n, and they have given the alpha value. The m we will calculate what gas they given. From there we can real molar mass, that is using general molar mass formula we can calculate. So after that, if we put the value, then we can get observed molar mass. So two type of questions they can ask from observed molar mass. So next topic is observed vapor density. This can represent as D. So from here, so definitions, this is, so observed vapor density, it is a density, of any gas with respect to hydrogen gas, or we can say observed density equal to density of any gas divided by density of hydrogen gas. So observed density is equal to molar mass divided by 2. So these are the relationship of observed density with molar mass. So here the observed density is equal to molar mass divided by 2. So I can write molar mass equal to 2 into vapor density. This is vapor density. Vapor density, observed density, we can write 2 into vapor density, observed vapor density. Correct term is 2 into observed vapor density. So for molar mass, previously says that observed molar mass equal to, that is m, small m, equal to real molar mass divided by total number of moles. So what I say is that molar mass equal to into vapor density. So observed molar mass is also 2 into so molar mass equal to 2 into observed density. Okay, so observed molar mass is also equal to 2 into observed vapor density. So what I say is observed molar mass. So molar mass is this. So molar mass is equal to 2 into observed density. So instead of molar mass, I can write 2 into observed vapor density. So I write 2 into observed vapor density, because observed molar mass, because molar mass equal to 2 into observed vapor density, and observed vapor density is this. So instead of observed vapor density, I can write 2 into observed vapor density, because molar mass equal to 2 into observed vapor density. So here 2, and real molar mass is also 2 into real observed vapor density. So real vapor density divided by total number of moles. So 2 here cancel. So observed vapor density, that is small d, equal to real vapor density divided by total number of moles in mixture. So what I understand, that observed vapor density and observed molar mass is same. So just like from these relations, we can calculate observed vapor density from molar mass, because molar mass equal to 2 into observed density. So in place of molar mass, we will put 2 into observed vapor density, and here 2 into observed vapor density, then the real molar mass. So real vapor density is also 2 into real vapor density. So from 2 to cancel, so we can derive this. So let's solve one example. I think I have bring one pros. This is the example. So at constant temperature, vapor density of N2O is found to be 40. Percentage degree of dissociation N2O at this constant temperature will be. So 2 N2O gas, it is going to give 2 NO2 gas. And T equal to 0, this is 1, 0, and T equal to equilibrium. So 1 minus alpha, alpha is consumed, so 2 moles, so 2 alpha. So what, at constant temperature, vapor density of N2O4 is found to be this. So this is observed. So at constant vapor density N2O4 is found to be 40. So observed vapor density, that is small m, is found to be 40. Percentage degree of dissociation N2O4 at this constant temperature will be N2O4 to NO2. Okay, so we know that m equal to, D equal to capital D, then total number of moles. So D is here. So for D, so how you calculate the vapor density? So calculations of vapor density, how will calculate? That is molar mass of that gas divided by 2. So here N2O4, so N is 14 into 2 plus, that is 16 into 4, that is 28 plus, that is 64 divided by 2. So this is how much? 92 divided by 2. So this will be how much? 4 ja 8, 2 6 ja 12. That will be 46. So real density is 46. So real density is 46 and total number of moles is 1 minus alpha, 2 plus alpha, there is 1 plus alpha, and observed density is given, that is 40. So 46 equal to 40 plus 40 alpha, then 40 alpha equal to 46 minus 40, that is 6, then alpha equal to 6 by 40, that is how much? 6 by 4, 1 4 ja 1, 2. So again this will be 1.5. So we can calculate the real density. So real density, suppose CO2, what is the real density? That is molar mass divided by 2. So molar mass is what? 12 plus this is 16 into 2, that is 12 plus 16, that is 32 divided by 2. The observed density, vapor density is molar mass divided by 2, right? So 16 plus 32, that is how much? 4 divided by 2, that is 22. Suppose if you ask to calculate the density, real density of SO2, then what? Molar mass divided by 2. So this molar mass is how much? This is 32, and oxygen is 16, 2 is 32 divided by 2, that is 64 divided by 2, that is again 32. So like this. So D for N2O4 real density is 46. We can calculate from that molar mass of N2O4 divided by 2 and total number of moles, that we will get from that equilibrium. So that is 1 plus alpha. So if you calculate, then of the alpha we are getting 1.5. So molar mass, observed molar mass and observed vapor density nearly same. Like vapor density, on that case we will just whenever you are calculating the real vapor density, we are just divide the molar mass divided by 2, and whenever you are calculating the real molar mass, then we are directly calculating the molar mass. So here also the same type of questions can ask. They will give the observed vapor density, they will give, and they will ask the alpha, or they will give the alpha and they will ask to calculate the observed density, because m D, that is real density, we can easily calculate by doing the molar mass divided by 2. So D we can calculate. Let me clear it. So observed molar mass is m by total number of moles present in a mixture at equilibrium, that is 1 plus alpha n minus 1, and for the density, that is D 1 plus. So like here they will give the m is given, then alpha is not given, so you have to calculate alpha. So m we can calculate, that is simply calculate the molar mass, and molar mass, then m is given, molar mass we will get, then n we can get from equilibrium, total number of moles present, total number of moles in product side. So n we know, m we can easily calculate, and m is given, then we can easily calculate alpha. This is the one type. Second type, alpha will give, m has to calculate it, m it will ask, then also we know m we know, alpha given, and we can calculate from there, so we can easily calculate the small m. Similarly for density also, density is molar mass divided by 2, so density we can easily calculate. So either D will given, ask alpha, or alpha given, D will be asked. So this type of problems can ask from object molar mass or object density. Okay, thank you.